Hello, welcome back. Today let's try to solve the Leetcode daily challenge 542, matrix. So let's read the problem. So we are giving a m times n binary matrix. So it means inside the numbers it is 0 and 1. Return the distance of the nearest 0 for each cell. So this means, for example, this is 0. So the distance to its nearest, it is itself. Yeah, so it is 0. And for this number, it is 1. So what is the nearest real 0? It means this one, or this one, or this one, and this one. So the nearest distance is 1. Yeah, because we are calculating the nearest distance. If this is 0 to 1, if it is a Manhattan distance, the distance would be 2. Yeah, let's see the distance. Yeah, it didn't say it is a Manhattan distance, but yeah, between two adjacent cells is 1. So it means it is a Manhattan distance, because here said the distance between two adjacent cells it is 1, because this one and this one will see it as adjacent. Yeah, we may think maybe this one to this one it may be adjacent, but it is not like that. Let's just check the example, because the example is like this. So it means the Manhattan distance, but the question didn't describe like that. We have to guess. It may be Manhattan distance, because here said two adjacent cells is 1. We think this to this one is adjacent. This one to this one is not adjacent. Yeah, it always depended on our guess. For example, we can guess the next one. So here 0, 0, and this is 1, this is 1, and this is also 1. So for this cell, the distance is 2. So it means it is the Manhattan distance. It's not other kind of a distance. Yeah, so it means our guess is right. Now we can solve the problem. We can solve this problem using multi-source BFS. What does that mean? It means we have a lot of sources. Yeah, we have a number of sources. So 0 is our source. For example, for this question, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 sources. What are we going to do? We just need to use all these sources to find the other grid, other numbers inside the grid, which is not the source. For example, 1 is not our source. So we just need to find this one and change this number. Yeah, we're gonna use the BFS. So first we're gonna use BFS to check this number. So for this number, BFS goes to here and goes to here. So we didn't find a new number because it is always 0. Yeah, but when we are using BFS, this 0 and this 0 has already been appended inside the queue. And then we're gonna loop this 0. So from 4 directions, there is a 1. When we find a 1, so we're gonna update the value of the matrix R and C. We're gonna call this matrix R and C. So how should we update it? We should just use this value from the matrix plus 1, because the distance is two adjacent cells is 1. This adjacent to this adjacent, they are adjacent, so we're just gonna plus 1 to here. And in this example, for example, we're gonna use the BFS, and this matrix, this grid xy, it is 1, and here 1, and here is 1. And then we're gonna use the BFS to check. Yeah, if this one gonna pop out the BFS first. Yeah, pop out of the queue first. Yeah, because we don't know, because we're gonna use the 4 directions, but the directions doesn't matter. If this is the first pop out, so we're gonna get a value, and here we should update it using this 1 plus 1, so it is a 2. Then we return our final result of the matrix. Yeah, now let me do it. Basically, this is just a multi-source template BFS question. Now, for me, normally I'm gonna use queue and visited as the queue and set. Then I'm gonna use R and C. It means the row and the columns of my matrix. Then I can loop through the matrix to find all my multi-sources. I mean the mounting sources is a 0. I need to find all those zeros. And at the same time, I need to deal with the queue and visited set. Now let's just loop through the matrix. So for R in range, why I use R and C and Q and visited? So these variables should always be fixed. You can use other variables, but it doesn't matter. So this is just the template. Because if you didn't use the fixed variables, you may make mistakes every time. Yeah, this is just for saving time. So for R in range capital R and for C in range capital C, let's check if mat RC equals to 0, we're gonna q dot append R and C visited dot add R and C. Here we can use a tuple or array, it doesn't matter, but we need to keep it assistant. Now, this is basically finished. It means we've already put all zeros into the queue and the visited set. After that, we're just gonna use BFS to check. So before using BFS, let me define another variable directions because I'm gonna use it later. So inside the directions, it will be 0, 1, 0, minus 1. It doesn't matter. I'm not going to check if this is up or down. It doesn't matter. I just need to find for directions. And here I find for directions. So this should be 1, 0. Now let me put this directions here. Yeah, because I'm going to define all my variables up here, and then I'm going to use BFS. So while q, yeah, this is just for making the code clean and as a template. For each of the problem, I'm gonna write this side of these 3 lines of code first for this multi-source BFS problem or the BFS problem. Normally we're gonna use these variables. Yeah. Now I'm going to pop out. So RC equals to code dot pop out should be always at the left for the queue. And then I'm going to check dr and dc in directions. Now I'm going to update my row and column. So this is a new row and new column. Our should be r plus dr and c plus dc. Now I'm going to check. So if row should be more than and equal to 0 and less than r, and column similarly should also be the same, more than and equal to 0 and less than column. And I also need to check the row and column not in visited. So this is the meaning of why I'm going to use visited. You can also use other method, but it doesn't matter. Yeah, because for this kind of method, we can just use m times n time complexity to finish it. Yeah, because this is really quick. You just need to, yeah, this is the source, and for the next one, you can start find this number. And this is the source for the next one, 1, 1. You don't need to use many loops through or DFS to search, because for multi-source BFS, you just need to take O m times n time. That is why you can pass it, because let's say the m times n is 10 to the power of 4. So this means our time complexity is 10 to the power of 4. It means we can pass it for all testing cases. Yes, let's just do it. So if that is not in visited, what are we going to do? So for our queue, should append row and column. Yeah, this is just the template. There's no much meanings. Just need to, yeah, there's no much explanations. Just need to, yeah, put the, when we are using BFS, just need to put the new row and column inside the queue, and put the new row and column inside our visited set. Visited dot add row and column. Now what we should do, we should also update the mat. So the mat with row and column should equal to our. So this means where are we coming from? So this row and column are coming from this popped R and C. So here should be R and C, the value of mat R and C plus 1, because they are adjacent, so the distance should be 1. So it should be accumulated by 1. Before it is 0 and now it should be 1. So here for this one, before it is 1, now it should be 2. Now let me just return the mat. I think basically this is the entire code. Let me check if there are any mistakes. Yeah, it seems okay. This is why we need to use a template, because everything is fixed. You don't need even to think about it. What you need to think is just to recognize the pattern of the problem. Recognize it is a multi-source BFS, and then you just finish your coding. Yeah, as you can see, it's pretty fast. It's nearly 78% of all Python submissions. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.